The end of the single-client era. Firedancer 1.0 is officially running on stable mainnet, ending Solana's multi-year reliance on a single validator client. This is not a simple patch or a performance tweak. It is a total reconstruction of the validator stack written entirely in C++. By introducing a second, independent codebase, the network has theoretically eliminated the singular point of failure that previously allowed a single software bug to halt the entire global state. This milestone marks the shift from an experimental monolithic chain to a redundant, multi-client system designed for industrial-scale throughput. Bypassing the kernel for speed. The performance leap in this new client comes from a custom networking stack that completely bypasses the standard Linux kernel. While traditional clients lose significant CPU cycles moving data packets between hardware and software, Firedancer uses memory-mapped access to read directly from the network card. Think of it like removing every stoplight on a busy transit route to allow a continuous flow of data at hardware-limited speeds. This architecture enables a single validator to saturate a 100 gigabit link, effectively moving the bottleneck from the software layer to the physical limits of the fiber optic cables. The memory safety trade-off. This transition introduces a massive engineering trade-off by moving away from the memory-safe guarantees of Rust. The original Agave client uses Rust to prevent common vulnerabilities like buffer overflows, but Firedancer opts for manual memory management in C++ to extract every ounce of performance. To mitigate the risk of catastrophic crashes, the developers implemented a custom framework for formal verification and strict sandboxing of every process. It is a high-stakes bet that rigorous auditing and hardware-level isolation can provide the same security as a safe-by-design language, while delivering 4 times the execution efficiency. This signal under the noise. The arrival of Firedancer Stable 1.0 proves that client diversity is no longer exclusive to Ethereum's design philosophy. By running 2 entirely different codebases side by side, Solana has resolved its most persistent criticism regarding network liveness and fragility. This transformation changes the calculation for infrastructure operators, who must now balance their stake between the Agave and Firedancer clients to ensure the network can survive a consensus failure in either one. It is no longer about how fast the chain can go, but about how many different ways it can remain functional under stress. For those building on-chain, the implication is a fundamental shift in uptime expectations for high-frequency applications. The most important metric to watch now is the stake distribution ratio between these two clients. The closer that ratio gets to a 50-50 split, the more resilient the underlying state machine becomes. Watch for the first major consensus mismatch on testnet as the definitive proof that the redundancy mechanism actually works. Subscribe for more